Alright, welcome. In this video I want to show you just how I've created this little heads-up display in my Super Mario Brothers. That is a display that will allow you to display any other extra information about your game that is not necessarily in your game world. So in some games this might be used to display some text about a selected object or entity, or maybe it is where you would display your mini-map or some other features. I happen to use it also to display my debug features, which includes my mini map among other things. And so here I'm just going to show you how to set up your heads-up display. Now, one thing I've done with my heads-up display is I've chosen to bundle it inside my scene manager. Now the reason I've done that is for two main reasons. Well, the first main reason is that it's sort of convenient to bundle a few of these things together. It maybe will be inconvenient to unbundle them because in some cases they are tightly coupled and you're going to want them to communicate with one another. For instance, one thing that I'm having the scene manager already carry out for me, and if you've watched my video on scrolling, you know that I use it to be the camera into the game world. It allows us to be the viewpoint through which we can see what's happening in the game world, and that's what I've been calling the camera. Now, the heads-up display, part of the reason why we call it a heads-up display is it's as though it is resting on your head. So if you move your head around, the display moves with your head. That's the origin of the name heads-up display. And so there's a way of thinking of it as being sort of taped or is fixed to the front of the camera, which is wherever you move that camera, you're always seeing this image, the heads-up display, the extra information that is also being displayed. So for that reason, it makes sense to couple the camera and the heads-up display together, even though conceptually you might have them separate in your mind as being sort of two separate entities. Now, I've also chosen to bundle this in with my scene manager, which is the thing that keeps track of which level I'm on and loading the proper entities for each level. Now, it's possible that we could decouple these. I don't think there's a necessary reason why this needs to be coupled into the same object as well. Perhaps it's just my own conventions that I've adopted over the years that I tend to bundle in my scene manager in with the camera and the heads-up display. Now, I've talked a little bit about the camera and the heads-up display, or the camera and the scene manager already. What I want to talk about in this video is just how I've displayed the various information onto the screen, and that's carried out for me in the draw method. And most of the draw method that I have here is actually dedicated to my debug code. As you can see below here, a lot of that is carried out inside this debug block. But maybe I'll just focus a little bit on my choices and my selection here. You can see here that I'm using this fill text command to print text onto the canvas, and it works fairly straightforward, but I might just point out a few peculiarities about it. The first thing that might be worthwhile noting is that I've chosen to select a specific font that captures the same type of 8-bit font that you might expect in an original NES game. Instead of creating the font by scratch or by hand, as was probably done in the original Super Mario Brothers, I instead looked for a font. I'm sure there was one out there already that someone else had created, and I found this cool one called Press Start to Play, or Press Start to P, and I've just used a little bit of style scripting here to load that in because it's not a standard font. This is a font that I'm loading from the Google font families. And so I load that in here. I've added this so I can access it. If you're using one of the standard web fonts, you don't need to add this in. But if you find some cool web font that you might find on the Google's font list, you can go ahead and load that in here. Now, this little bit of style is going to set so that the font inside the body of my web page is going to be using this font at 24 point. And that's what's setting the style of the Super Mario Brothers title at the top, and then my little debug at the bottom here. But as you might expect, when you want to write to the canvas, it's not going to use the basic style set up inside the website for whatever component of the website you're in. It's instead going to have its own font settings, and just like some of the other settings, we're going to have, these are global settings for the canvas or for the context. So when we set this font, it will set the font for anything we write on the canvas. Now, I end up doing this every time. I could just do this to start out, and the font will always remain this way, but this is just in case I might change the font and want to write in different fonts on different parts of the canvas. I've also chosen to fill my text. We have the opportunity to do a stroke text or fill text. Stroke will just draw the outline of the text, whereas fill will fill it in. And of course, you can set it up to do both, and that will give you sort of a border around your text. Now, again, I'm just trying to mimic the original Super Mario Brothers, so I'm going to have a white font. And again, I'm just going to try and write onto the heads-up display exactly that information that I want to display. Now, in the original Super Mario Brothers and in some of the other original NES games in the older 8-bit world, because writing text arbitrarily on the screen was a little bit difficult, sometimes what they would do is they would fix what they were writing on this screen in some predetermined way so that they knew exactly where the letters would go, and they don't have to worry about, text going off the edge of the canvas or something like that, or not fitting or overlapping with one another. And a couple of the choices that they made, for instance, they pad the score here with zeros. And the same thing was done for the time, but only for 3 digits, since it started at 400 rather. And the other thing that happened is that the actual number of characters used here was fixed in each one of these blocks and known ahead of time. For instance, world here was going to be 5 characters. They positioned the 1, 1 here and the 2, 1 and so on, so that it was sort of centered there. This was all predetermined ahead of time, and the word that we type there never changes, so we never have to reposition it. Now, that's what I've done in my coding here as well. So maybe I'll just show you. So most of what I have here is just each of the things that I want to type, but with the appropriate positioning. Now, one thing that's important for us to note is that when you actually want to draw something on the canvas, we usually draw from the top left corner, say if we're drawing an image or a rectangle, if we haven't changed the canvas parameters in any way. However, when we draw text, we draw from the bottom left-hand corner, which can be a little bit confusing at first. I'm not certain why they chose to do this. Perhaps it's just traditional. We usually think writing text would happen from the bottom left. Well, we would also think that of drawing a rectangle, but we didn't change that. So I'm not sure why they changed one and not the other. But this is something to keep in mind when you're actually drawing, that you're going to be drawing from the bottom of the text and not the top. And so the positioning, the XY where you position it, is going to be that bottom left-hand corner of the text box that you want to create. So that's one thing to consider. The other thing I've done here is I've done some padding. So I've used this little bit here. Now this is sort of a bizarre bit of design pattern here. What I've done is I've taken this dot score, which we know is a number, hopefully. And by adding on the empty string, this is just a way of telling us in JavaScript to basically cast this as a string. By adding on the empty string, it will turn it into a string. And then once it's a string, I can call this string function, which is padding, which will pad any string you want. And what do? I want to pad it with zeros up to how big it was, 8. Now, one thing I'll mention, because I'm calling this Super Marriott Brothers after my name, the original one just says Mario at the top, which is 5 characters long, and it actually, I think, only pads its score up to be 6. But since my name is 8 characters long, I chose to pad up to 8. Now, again, this is just drawing the score underneath the name Marriott, and then we're also going to have the number of coins that are displayed. Here, I could have used some padding as well, but it was simple enough that it's either going to be, the coins cap out at 99, so it's either going to be 1 digit or 2. So I just said if it's less than 10, we'll just add that extra 0 in, otherwise we don't. And then we'll add on the number of coins there are, so that just displays the number of coins. Now if we notice in my heads-up display, there's also this animated coin that is used to show how many coins I have. So I also display that, but I do that down below here with this coin animation. And you can see it's slightly off centered, whereas the text for that line is drawn at 1.5. The actual coin is drawn at 1, and again, that's just because of the differences between drawing the images from the top left and drawing the text from the bottom right. And the rest of these lines here are just set up to display the rest of the text. Again, I put a little bit of time into positioning them, but otherwise I'm guaranteed I don't have any countdown for my timer yet. It's just hard-coded to 400. But if I did actually build that in as well, it would use just a little bit of logic like these ones, where it will display whatever the time is with possibly padding a 0 or 2 at the front as needed. Now, I've also found it helpful in my heads-up display to put in any debugging information that might be convenient. Now, sometimes you just want to output debugging information to the console, but in a real-time game like this, or a game where you're getting updates many times per second, that can result in just a lot of console log output that is really kind of hard to read. It's sort of like reading the Matrix or something. You need to watch it go by real fast and see what's happening. So instead, it's usually convenient to have some of your variables maybe being just displayed on the canvas. And so I've done that when I was debugging Mario's physics. It was helpful for me to know what his vertical and his horizontal velocities were. And so I just went ahead and I captured the velocities of Mario. I also ran them through the floor function just to truncate. Otherwise they become these really long decimal numbers, and I didn't want them to overlap with some of my other displays. But otherwise I'm just displaying some variables that might be useful, and you might want to create your own debug output on the screen. And if you're familiar with certain games, for instance, one comes to mind is Minecraft, you can turn on its debug display while you're playing, and it will give you a little bit of extra information while you're going. Now again, this is usually only useful for someone debugging, but it could potentially be useful for someone playing the game as well. Now, all this logic here, if you saw my video on keyboard input, this is the logic I inputted to just capture which keys were being pressed at any one time. You could use this to debug your own keyboard input. And then I've also added just the minimap drawer down in below here. Now, this is something that you might want to do as well. I've bundled my minimap into the heads-up display just because, one, it's usually displayed as part of the heads-up display. And so again, even though we might be conceptually trying to separate the behaviors of these different objects, I've sort of bundled them all together for convenience because they all sort of have to rely on the same information. Finally, while the Mario heads-up display is actually very simple, and this was true in a lot of the earlier games, the more modern heads-up displays often come with some images packaged as well, not just a simple coin animation like this, but maybe an image sort of showing what the display looks like, that the image itself never changes, but what is displayed on that image does. We might sometimes call this an overlay, and if you have an overlay yourself, you might go and work on one in Photoshop or GIMP that has, for instance, a number of transparent components to it, maybe a transparent component where you would insert the minimap, or a transparent component where you would put some text. Then usually what you're going to want to do is draw that overlay last. And this is true of everything about the heads-up display, but also of an overlay as well, since in the canvas you want to draw things in the order that they should be displayed, that the last thing you draw will be on top. So you usually want that overlay to be the last thing you draw right after you draw these different elements of your heads-up display. Now, how have I chosen to take care of that? Now, there's a couple ways you can do that. One is to remember that inside your draw and your update in the game engine, that we're going to call draw and update on our entities in the order of the entities. So what order we place them in is important. For instance, if we want the camera to be drawn last, it should be the last thing we put in the list of entities. Now, what I've done instead, because I want to ensure that the camera is always the last thing, and I might be creating arbitrary objects like fireballs and things, or power-ups and coins that just pop in and they appear and then they disappear, because when I add them to the entities, they will probably be the last things in this entity list. And I don't want them to be. I want the camera to always be the last thing. There's a couple ways you could handle that. Maybe make a priority queue or some other data structure that would handle that. But instead, what I've chosen to do is I've just privileged my camera altogether. I've broken it out of the entities list altogether, and I just give it its own opportunity. The camera is always the last thing that's going to update, and it's always going to be the last thing that is drawn. I've chosen it to always be the last thing to update because the camera moves with Mario and I want the camera to update after Mario has updated. So don't want to have the bug where Mario moves after I've moved the camera, and therefore the camera is not precisely centered on Mario. I also, as I mentioned, want my camera to draw last so that it is drawn on top of everything else. So if you have your own scene manager object, camera object, heads up display object, and you want to ensure that it is always drawn last, either have some kind of priority queue or use some logic to make sure it's always last in your entities list, or do what I've done here, break it out and give it its own privileged role inside the game engine. All right, that's all I wanted to say about the simple heads-up display in Super Mario Brothers. And so thanks for watching, and we'll see you in the next video.